So this is the next example, which is example number 7. It's a pyramid, and pyramid is massive, as in massive in terms of the real world pyramid, and also in this particular example, as we will see later on. So it's pretty nice that you have much more constraint over here. Is given that the base is equal to 2x, and then the volume is also fixed for 4 over 3 okay, meter cube, or is it centimeter cube, right? It's okay, as unit is not particularly important, but although the constraint is given more than usual, but definitely it's just ample enough for us to tackle this particular question, because pyramid, again, this example is very hard example, so try to stay with me. I'll try to explain it as good as I can. So it's a pyramid, okay? So when you are dealing with pyramid, you need to take a look at this 3D structure to understand about pyramids. So pyramid consists of the base, you can call the base as B usually, the height, which is inside here, and the slanting height. Slanting height, there's a lot of letter used for this particular to resemble this line over here. Some people use small s, maybe y, or maybe any other letters out there. So this is basically the B. Okay, so definitely it's a square base. You are talking about this side, and this side is of the same length. You can use a B, right? Just B, or you can rewrite it in 2x directly, is also possible. So this part is what I would like to point out here. In order for us to find the slanting height, you need to use this h, and also this part, which is half of the length of the square, is an x. Okay, you can try to draw this in fully, right? Then you can see that this length and this length is half of it, because the height is directly in the middle of this particular pyramid. Okay, so that's one done. Firstly, you need to show the total surface area is given as that ridiculous expression, but that part is still okay. The next part will be much more hideous when you try to differentiate something that is ridiculous as it is, and then trying to obtain the final answer. Everything is given in this question. The constraint is given, the answer for the first part, the answer of the second part is also given, but trying to go there is a work in itself. So let's start off with our first constraint, which is the volume of pyramid is equal to 1 over 3 the base square multiplied with the height is equal to 4 over 3. Okay, so I need to save a lot of space for this one. You know what will happen over here. You just simply substitute the b with 2x, and then you can get your 4 over 3 equals to 4 over 3 x square h, and that is why your h is equal to 1 over x square, or I'm using x negative 2 over here to achieve to our answer for the first part easily, because there's a power negative 6 over there, so we need to write our x in the power of negative wherever we see this. Okay, so that is the first part done. Now that we have this h, we need to find the slanting height, because the total surface area of pyramid consists of the base and also the slanting height. So you need this small s now. So s is going to be s square, sorry, is going to be x square plus h square. So you can say that your s is equal to a third of x square, and take a look at this. This is a h to the power of 2, negative 2, and then you're going to power it with 2 more, then you will get x to the power of negative 4 already over here. So whenever we see a power that is higher than 2, we are already scared. Okay, not only in your case but also in our case as lecturer and teachers too. Alright, so let's do this total surface area for the pyramid. So the big capital letter S over here, not to be confused with the big then you have B, a small letter S over 2 plus B square. This is the total surface area formula, right? So this is 4 times of the you can see that the slanting face of the triangle. Just now we have a slanting height. This triangle, the triangle from the bottom towards the top side of this triangle is they usually call this one as the slanting face of triangle. So it's just a small triangle where you have the base multiplied with the height divided by 2. So now there are 4 of them. That's why the formula is something like this. And since the base is a square, it's just a b square. Okay, alright, so this one is easy. Just substitute with whatever value that you know. You will see you will arrive to up to something like this. So you have a 2x and then a third x squared plus x minus 4 and plus 4x squared. Okay, this is already tedious in a sense, because the question asks us to show that it's in the form where you have a 4x squared outside. So let's take a look over here. If you try to factorize 4x squared over here, make sure that you know that this one is 2 multiplied with 2 multiplied with x, it will be just a 4x. So there is a missing of one more x. So because it's missing one more x, then you need to increase it by, replace it by an x on the bottom side. Then if you you can check this one back. Let's say that if you are wrong on this one, try to multiply back this 4x squared into this one over x. Do you get the 4x over here? Definitely you will get it is, because this one is correct. And you have x squared over here, and then you have x minus 4 over here, and plus 1 on this side. Now in order for us to really show it is as it seems in the question, you need to drag this 1 over x into the third of this expression or this term, so that you can get the final answer, which is, I'm taking the one from this side towards the left just to follow the question requirements. This one, when you take it inside, it will become a third of 1 over x squared, because treat the thirds like a person's home. Whenever you go into a person's home, then you need to follow his or her rule, and this rule states that everything inside must be squared. Okay, so that's why when x goes inside, then it needs to be squared first. Then you have x squared plus x minus 4 divided by x to the power of 2. So since the denominator is just one term, you can separate it into two sides. So you have x squared divided by x squared, then you become a 1. This one is x to the power of negative 4 divided by x squared, meaning x to the power of negative 4 minus 2, then you have x to the power of negative 6.